How do we express the set A consisting of the elements 42, 49, 56, 63, etc. up to 140 in set builder notation? Well, let's first see if we can figure out what the pattern is for A, and you should try to figure this out before I tell you. Pause, figure. But I'm going to say that 42, well, let's see, 49 minus 42 is 7, 56 minus 49 7, 63 minus 56 is 7. It looks like these things are gone up by 7, starting at 42. And of course 42 is a multiple of 7, it's 6 times 7. So we can write this then as a set of multiples of 7 between 42 and 140. Okay, so let's first, we're not going to actually write it this way, but describe it. This is the set of multiples of 7 between 42 and 140 inclusive. Now that's a verbal description of the set. Let's try set builder notation. We could say that A is a set of X such that X equals what? Well, if it's a multiple of 7, it's 7 times some counting number, so we're going to say equals 7n. What are the counting numbers? Well, n would be 6, 7, 8, and so forth, ending at, well, 7 times what is 140? You can figure that out. That's 20. So this is a way that we could write it. Now we could, this is really the best way to write it. Not quite as good. We could say A is a set of X such that X is a multiple of 7. And 42 is less than or equal to X is less than or equal to 140. This isn't as good because it doesn't give you a really specific rule in terms of some counting numbers, and notice that these numbers are real predictable, 6 through 20. Okay? Now this is equally predictable, but this rule is a little easier to follow. If I tell you this, then by substituting n equals 6, 7, 8, 9, 10 up through 20, you get all the X values that should be in the set. If you do this, you have to understand what a multiple of 7 is, and you have to read this. And this is really not as simple as this, although this is a little easier to get to than this. On a test, this would get you points, but this would get you all the points. Okay, now what about this one? What's the number of elements in A? What's the cardinality of A? A being the set that we just looked at. Well, how many elements are there? We could count them. We count them in our fingers. 42, 49, 56, 63, 70, 77, 84, so forth. That's not a good method because if this number is too big, we don't have enough fingers. Actually, we don't have enough fingers for this one, although we could still count it in our head. But what if this number was 385 million and something? We'd be in bad shape if we were trying to count in our fingers. So that's not a real good way to do it. We want to be a little more analytical than that. Well, another thing we could do, though, if we got this, we can see that it's 6 times 7 up through 20 times 7, right? Now, how many numbers are there from 6 through 20? You might subtract 6 from 20 and get 14 and say that there are 14 numbers between 6 and 20. But actually, if you count them, you'll see that there are 15. If we do 20 minus 6, we get 14. Well, if we did 8 minus 6, we would get 3. we would get 2, I mean, where there are 3 numbers. There's one more number than the difference here. That's kind of a fence post thing. If you're counting fence posts, you don't just count the intervals between the fence posts, you count the posts themselves. It's a real common error to be off by 1 in that kind of counting. That crops up again and again with computer programmers. One of the most common computer programming errors is to miscount in this way. In any case, okay, we could say A consists of 6 times 7, 7 times 7, 8 times 7, up through 20 times 7. Let's zoom back a little bit here so we can see everything. Okay. From 6, 7, 8, up through 20, there are 20 minus 6 plus 1 for the starting number, which is 15 numbers. So the number of elements in A must be 15.